So in this video, we're going to just go through the lab that we just talked about. So in the last lesson of the course, it's called Hands-On Practice, and I linked you to an AZ-104 lab from GitHub. I should point out that this is an official Microsoft lab for their official training. And so it is really good. There are, 9 contributors to this. And I wanted to say kudos and thank you to all 9 people for creating a set of labs that's really interesting. I do highly recommend you go through this. So if you skipped over that and you just want to watch videos, please consider going to GitHub and running through this. The instructions are really clear. In this video, I'm going to go through the lab step by step. It's going to be a long video. Microsoft estimated 60 minutes. That's not too far off. I was able to go through this in about 45 minutes. And that's the length of the video. So if you're interested in following along, this is the video. If you had trouble with it, this is where I go through it myself successfully. Otherwise, you are able to skip this video. So if you're in the Udemy course and you're watching one of my videos and you're like, no, this is a 45-minute video, there's this white box and you can click it and its check mark comes up and you can skip the video. So if this isn't what you're looking for, that's great. Skip the video, continue with the course. Otherwise, we're going to go through this lab line by line. We're going to follow the instructions word for word, and we're going to end up with a hub and spoke network with virtual network peering between the two spokes, between the spokes and the hubs, I guess technically. We're going to configure routing so that the spokes can talk to each other through the hub and have both a load balancer and a gateway and be able to test that they're working. Lots of great stuff. It's a long lab, but we cover a lot of the networking topics, so thumbs up. Now, the first task of this hands-on lab asks us to go to the portal, sign in, and get into Azure Cloud Shell. As you know, Azure Cloud Shell is this > symbol in the top. There's also a standalone version of Cloud Shell called shell.azure.com. So you can basically sign into your Azure account using this, and you've basically got a full screen version of Cloud Shell that's not dependent on the portal. So you've got both options available to you. Now, so if we have to sign into Cloud Shell and we need to be in Powershell. Now we do need to download the files from the GitHub. Okay, so we're going to upload these files from GitHub into Cloud Shell. The way we do that is we're going to go and download the files. So if we go under up to here, we can download a zip file that contains all of the labs. I can open it up. And we know we're going into lab 6. So I go all files, labs 06. And so I'm going to copy this 06 into my downloads directory. So now I have this extracted from the zip file. So what it wants us to do, I'll go back to the instructions here. What it wants us to do is upload those 3 files into the Cloud Shell. So I can switch over to the Cloud Shell. I can click Upload and go into the 06 and pick all 3 files and say Upload. And now it's uploaded. So if I ls star.json, we can see the 3 files. We have to do this one at a time. Thought I would be able to do all 3 at once. Okay, so if we ls star.json, we can see the 3 files for this lab. Next, we need to create a resource group. Now I can copy this script here, replace the region with the region that we want. I'm going to sort of compromise here. I'm going to copy 2 lines of it, paste with Shift Insert, and the location I'm going to use is I'm going to use East US. And so I'm just going to put it as one word, East US. And we can see that the resource group succeeded. Next, we want to go back to the instructions, and we're going to deploy the ARM template. So this VM parameters.json has the parameters, VMS template has the VMs. Okay, so this is going to create the first virtual network and deploy a pair of virtual machines into it. So we'll paste that in there, and it's going to execute. Now it's a long-running job. It since this ash job parameter basically has fired that off, and we've got our deployment started. We have our command line back. So we're just going to move along, do the next one. We can see we're creating another resource group here. Now I have not set this location property, so we're going to have to do the same trick where we say East US. That's created a second resource group, and now we're going to deploy another virtual machine. It's a different template, the same parameters. Now we got 2 jobs running. We're just going to keep going. It's got a third resource group, East US. And it's going to deploy the same virtual machine that it did for the second group with the suffix 3. So now we've got 3 jobs running. Now it says wait for the deployments to complete before proceeding to the next task. To verify the status of deployments, you can examine the properties of the resource groups you created in this task. So let's go to the portal, and I'm going to go to all resource groups, and we can see we've got 3 resource groups going in East US region. We have going to deployments. It is still in a deploying state, so we'll wait for this to complete deploying. So while we're waiting for these to complete, we could go over to GitHub. I'm going to make a new tab here, and we can go up to let's go look at the JSON for the template. So it's lab 6. We've got 2 templates and 1 parameters file. So the first one we deployed is this VMs with a plural. And when we open it, we see a number of parameters that are passed through, a number of variables that are created and set, and we can look at the different resources. So remember, with ARM templates, everything under this resources is where the actual work gets created. So we've got a set of virtual machine. We got a virtual machine here. It depends on the network interface card, so it doesn't get created until the network interface card does. You've got a computer name, admin password, admin username, hardware information. We can see that it's deploying Windows 2019 Data Center, latest version. Now we can see that there is a virtual machine extension that's being installed, and that's the custom script extension. A really interesting piece that's happening here is there's a PowerShell script embedded in this template. So you can see it says command to execute PowerShell.exe, and then it runs a number of commands. It's installing a web server, so you don't have to remote desktop into it to install IIS. It is deleting a file. It's deleting the IIS start homepage. And then it's adding a new IIS start homepage that says a string hello world and has the computer name. So this is HTML file is just going to have these 4 words in it, let's say. Very interesting like script that's being passed in. It'd be interesting to see that work, right? There's a second virtual machine in here. Everything is pretty much the same, again with the custom script that's being installed. Virtual network that's being created, 10.60. Let's go back to the portal. Refresh. That succeeded. Let's check the other groups. Deployments. That succeeded. And third group, deployments. So all 3 of our deployments have succeeded. Now, if we go back to the instructions, we waited for the deployments to succeed, and it says close the Cloud Shell. So we're not going to use the Cloud Shell anymore. And now we're going to go into the virtual networks, and we're going to set up a peering relationship. So this is setting up what's called a hub and spoke topology. What that means is you've got one virtual network, which is considered the hub. If you think of a bicycle tire, that is a hub and spoke. So you've got one virtual machine at the center of the bicycle tire, and then you've got other virtual machines that are coming off of it. And if one virtual machine wants to talk to another virtual machine, they need to go through the hub. So this is not our setup exactly, but this is a good representation where you have one set of virtual networks that connects to 2. And if this one wants to connect to that one, it has to go through the middleman. And that's called hub and spoke. So the next instruction here then says we're going to add a peering from 1 to 2. So we created 3 virtual networks. We're going to connect 1 and 2 using a peering between them. So we're going to go into resource group 1. We're going to go into virtual network 1. And if we go down onto settings, we can see peerings. And right now, this network is not peered with any other network. So we're going to click add. And we do have to name the peering. Now the instructions does suggest a name here. So we're going to use that name. We'll, of course, use resource manager model. We're going to connect this to resource group 2. And we have to add the connection the other way. So this is the backward connection. So the name of this is 2 to 1. As you can see, it says 0, 1 to 2, and this is 2 to 0, 1. Okay. We're going to enable two-way communication. And we're going to disable allowing 2 to connect to 2 to forward traffic from 2 to 1. But we're going to enable 1 to forward traffic to 2. So this is, if we go back here, the spoke can forward traffic to one of the hubs, but the hub can't forward traffic to the spoke. All right. And we don't want gateway transit. Okay, so we'll leave this unchecked. And we have to wait for this operation to complete. So this is going to establish 2 peerings. We're going to see it listed here in one of them from 1 to 2. And if we went over to 2, we would see 2 to 1. All right. So this little thing is telling me that the 2 to 1 is still deploying. All right, that succeeded. Now we need to do the same thing we did from 1 to 2. We're going to do from 1 to 3. Okay, so we'll scroll down here, and we're going to basically add in 1 to 3 peering. So same blade, 1 to 3, virtual network. You can see that it's one of the only choices. And then we have to name the reverse name, 3 to 1. Same, we're allowing two-way communication. We are not allowing 3 to forward traffic to 1, but we are allowing 1 to forward traffic to 3. And the gateway transit is unchecked. So now we have the connection from 2 to 1 and the connection from 2 to 3. And if 1 wants to talk to 3, it goes through 2. Next up, it wants to do a test, but the way to do the test is using Network Watcher's connection troubleshooter. So we'll do that next. All right, so the instruction says go to Network Watcher, which I see here. And what we're looking for is the East US region. So that is where we are. It is enabled, which is very good. And we want to go down under here to Network Troubleshooter. This is our subscription. We're going from Resource Group 1, Virtual Machine 0. Specify manually according to the instructions here. Resource Group 1, VM 0, specify manually. That's the IP address, port 3389. Port 3389. And we're going to check to see if Resource Group 1 Virtual Machine 0 can connect to Virtual Machine 2, right, according to this thing. The initial check can take about 2 minutes because it requires installation in the virtual machine agent. All right, well, let's do it. It's doing a deployment. All right, and so after a couple minutes, it says reachable. So this Resource Group 1 Virtual Machine 0 is the hub, right? So this is the central hub of this topology. And what we've successfully done is we've successfully communicated with a virtual machine in one of the spokes. Okay. We need to do the same thing for this machine, which is in another of the spokes. So I'm going to put that IP address out there, and I'm going to say check. So that took less than a minute, and we can see that this is reachable. The hub can connect to the other spoke, and so the peering relationship does exist. Go back to the instructions. We can see that that's our intended result. Now, the third thing we're going to check is the connection between the two spokes. But we're expecting in this first pass that it's not going to work because we've not yet set up the IP forwarding between the two machines. So we're going to go to the Network Watcher and go from Resource Group VM2 to this IP address. So here's this. Go to Resource Group 2, VM2, 2. So this is to go from here to here. Let's try that. Now this agent does have to be installed on the new VM. We'll give that a couple minutes. So that's a very interesting result. It actually came back as unreachable, But like we said, this is the expected result. This is because even though the network was configured to allow forwarding, the virtual machines in the middle are not set up. So the network interface card and the operating system doesn't allow forwarding. So you've got some devices that need to do some work here. So what we're going to do next in this instructions are to configure it in the VM itself. So we're going to go over to VM0 and we're going into the network interface card and we're going to set IP forwarding to enabled. So we'll go to dashboard, we'll go to resource group 1, VM0, networking. So click on the network interface blade and then IP configurations. IP configurations. And so at this is the device in the middle, and so it needs to have IP forwarding enabled. And I can say save. And then we need to run a PowerShell command in the VM itself. So we're going to go back up to the VM. We're going to go down under operations and say run command. We want run PowerShell script. And we're going to pass in this script, right? And click run. We have to wait for that to work. So this command came back, it says success true, exit code success. Now we do also need to run another command. So I'm going to say run PowerShell script. And the next commands we want are going to be this group of them. And so we can see what they're doing is that they're installing routing as a Windows feature, installing remote access PowerShell as a Windows feature, then this VPN, routing VPN, and then updating the Windows side of the network interface card to allow forwarding. That's at least what I think it's doing there. So let's just blindly run it. So those commands came back success and success. Assume that's the expected result. So there's still quite a lot of instructions to go to here. We do need to, now we have the networks that have got that allow forwarding. We've got the virtual machine in the hub that will perform that task. Now we got to set up the routes. Okay, so there's a thing called a route table, and this is what's going to tell Azure how traffic gets directed across your account. So I'm going to go into route tables. I'm going to say create route table. And the instructions do come with a very specific route table to create. So this is going into the RG2 resource group. The route tables has that name. We're going to put this in the East US region, same as everything else. And we're going to say no to gateway route propagation. So this is not going to broadcast this route. And I'm going to say review and create. And then we're going to say create. Now, apparently it takes about 3 minutes for this, so we're going to let that run. So that did not take 3 minutes. Go into it. The next instruction has us add another route. And so we're going to basically tell the route that it's going to have to forward the traffic through a virtual appliance. So we go under route tables, we go under routes, we add this route, give it a name according to the instructions. This whole network has 10.63 address. We're going to forward it to the virtual appliance, and remember, virtual appliance is asking for it to be forwarded to another network. Now we also have to associate this route to the virtual network. So we'll associate with this with the VNet 2 virtual network and subnet 0. So we created one route table that has a route on it. We do need to create a second route table. So I'm going to say add. We're going to put this into the resource group 3, which is the other subnet over here. And I'm going to put this in the East US, same as what I've been using. And we're going to call this route table this. So the instructions for this route table actually don't say to turn off the propagation. You'll see that that requirement does not exist here. And it says leave others with their default values. And so we're going to leave this propagation on. And then I can say create. Now the route table without the route isn't going to be very useful, so we're going to create the route. And if we go to the resources created already, go into routes, say add, give it a name. The address prefix is 62, virtual network appliance, and we're going to the .60 network, virtual machine. All right, then we have to associate this with the VNet 3 subnet. Associate VNet 3, subnet 0. All right, now we go back to the connection troubleshoot. And we're going to check to go from VM2 to the 10.63 subnet, then so again, this diagram doesn't say the IPs correctly, but we're going to go testing from here to here. So let's go to the dashboard. Let's go to Network Watcher. Make sure East US is still enabled. Go to the Connection Troubleshooter. And this time, we're going to, according to the instructions, go from resource group 2, VM2, to this address. Specify manually 3389, which is RDP port. Now the results of this is going to tell us either it's reachable, or if it doesn't work, then it's going to say unreachable. And so we should restart VM if it says unreachable. And it comes back and says it's reachable. So we can get from VM2 over here to VM3 over here through VM1. Even the numbers are wrong on this diagram, but anyways, pretty good. Now there's more to this, right? So now they want us to implement an Azure Virtual Machine, a load balancer. I mean, not an Azure Virtual Machine, a load balancer in front of the two virtual machines in the hub. Okay, so we're going to create a new resource group, create a load balancer, and with these properties, right? So go here, dashboard, resource groups, create a new one. East US is tends to be our region. And then in 4, we're going to create load balancer. We could have created the resource group in here. Now the instructions do say that there's a name and a public IP address name. Public SKU, okay. I'm going to create this in East. Public, it says standard, right? And then the public IP address is that. All right. Didn't like that. Oh, availability zone. So the answer is zone redundant. So that was quick. We can go to resource. The next requirement is to set up the backend pool. And so we're going to put VM0 and VM1 into a load balancer. Is there a name for this? And we're going to put 0 and 1 into the load balancer. All right, add. We're going to create a health probe to port 80. So that was done. We go into make sure, make sure they're both running. We create a health probe, port 80, 5 and 2. Those are the settings that we want. And say OK. And then we need load balancing rules. This is what's going to determine how the traffic is distributed. So we're going to take traffic on port 80, forward it to port 80. Yeah. There's the name, front end IP address by the default, traffic from port 80 to port 80. To the back end pool 1, health probe 1, session persistence none, 4 minutes idle timeout, disabled, disabled, and yes. So those are the settings from here. All right. So we're going to wait for this rule to be created. Now, this is the real test, right? So we have this public IP address, which I can just copy. I expect when I go to the public IP for this, I'm going to be presented with one server or the other. Now, the interesting thing about this code, remember we saw in the PowerShell in the ARM template here that it should say hello world and have the computer name as part of it. If this didn't work and it just shows me the default, it's not necessarily a failure. So let's open a new tab. Let's put in the IP address. And now it says hello world from 1. Okay. Now the instructions want us to try private mode browsing to see that that's going to change. So I'm going to say it's over here, right? Incognito window. So that says 0 and that says 1. So I'm super excited. It's been successful so far. And kudos to the people that contributed to this and to who wrote it. Microsoft has always been a very developer-friendly company, lots of free documentation, and this is no exception. The last task here is to implement an application gateway. Now, go back to our diagram here. It's going to put an application gateway in front of these two virtual machines running on these spokes. So there's one VM over here, one VM over there, and the application gateway is basically going to be in front of both of them. So what we're going to do is, this should hopefully be very quick. We're going to create a new application gateway subnet in VNet 1. So go up to the dashboard, resource group 1, VNet 1, subnets. We've got 0, we got 1, and we're going to have application gateway. This one is going to be 10.60.3. Okay. Everything else with default values. So no security group, no route table, none and none. All right. Brand new subnet. And then we're going to create an application gateway. Okay. Refresh this. We've got that there. Application gateways, create resource group 5 is the new resource group. And this is the gateway name, standard v2, all 3 availability zones. All right. So there's the name. I'm going to put this in the same region as the others, East US. Not auto-scaling, not enabled. We only need 1. We'll put it into all 3 zones. Disabled. VNet 01, we created a brand new application gateway subnet. On the front end tab, it's going to be a public one. Let's go down here. So there's a new public IP address. On the backend tab, we're going to create a new backend pool. It has a name. And we're going to put 62.4 and 63.4 in there. IP address 10.62 and 10.63. Those are the 2 VMs running in the 2 spokes. All right. Next up, we have the routing. So we need to have a routing rule. There'll be a rule and a listener on port 80. There's the rule. There's the listener. One public IP. HTTP 80. All right. Okay, on the backend targets tab, we're just going to pick our backend pool. We need to add a new HTTP setting for port 80, and we're going to disable affinity. So there's the name, 80, disable, disable, 20, add. And now we can say review and create. And then we're going to wait for the gateway to be created. Hopefully this is it. I mean, I thank you guys for sticking in here. If you've made it this far, we are going to have to get the public IP address of the application gateway, and we'll test it. So go to resource group, go to the gateway. We've got the front-end IP address. We're going to paste that in there. So remember, we are testing the spokes, so 2 and 3. So VN2 responded. Two responded, and there's 3. So we have successfully gone through lab 6 of this of AZ-104. The last step is to delete all the resources, which is always a good idea because as you can see, costs can start to run away. If you're on a pay-as-you-go plan, you start these up, you go for dinner, you go to sleep, you come back the next day, things start to run up. So for this one, I'm just going to open up the Cloud Shell in the browser here. And I'm going to copy the command here, which will well, this command is just going to list them. And we can see the resource groups. And this command lists them and then pipes the result into remove. Well, say goodbye to all that work. I find that it does that sometimes, but anyways, we can see there's a bunch of jobs running. It's done some stuff in the background here. So if I do close this, we will start to see the 5 resource groups that we created will start to have the resources deleted and the resource groups themselves will disappear. Thank you so much for checking this out. Hopefully that helped you. I highly recommend GitHub, Microsoft Learning for the AZ-104 labs. This is a good way. We spent 45 minutes here going through this. And if you do this all on your own, it's a good 45 minutes of practicing with Azure. Especially if you take the time to read the ARM templates and understand what's going on. Try to picture in your head how resources are talking to each other when something works, why it works, where the traffic is traveling from the hub to the spokes and then back, etc.